Good morning, everybody. I won't be in class today, as you can probably already tell. I've got one kid that's sick and a childcare conflict with the other, so I'll be teaching via the Explain Everything today. We're going to graph exponential functions, two types. As you can see here, these two functions are both growth functions, and this function here is an example of a decay function. We'll graph those. We'll talk a little bit about exponential growth, exponential decay, as well as identifying limit notation for end behavior. We'll continue on the next slide, so let's get started. Okay, everybody, so let's start with exponential growth. I've written out our function, y equals a times b to the x power. As you'll notice, our base here, b, sorry about that. Our base b is our growth factor if and only if b is greater than 1. So as you'll see in problem number 1 here, I have a base of 3, obviously greater than 1. Number 2, 1.5. Number 3, kind of sneaky, but I'll show you what's happening here with the exponent. This is a positive base of, a base of, okay, hold on everybody, a base of 0.6 to the negative 1 power, which is actually 10 over 6. So I'll show you that here on the next slide. And our last one here has a base of e. Now you're not aware of possibly what e is yet, but depending on your background from higher algebra, but I will explain on the next slide. Okay, so the first two examples on the previous slide were very basic. Their base values were greater than 1, which was easy to identify. Problem number 3, though, doesn't have a base value that's easy to identify. As you'll see here, what I can do algebraically is take 0.6 and write it as 6 over 10, which is definitely less than 1 and greater than 0. However, with a negative exponent of 1 or negative 1, what I would do algebraically is swap the 10 and the 6, and now my exponent is a positive 1x. Therefore, now I've located my base, which is 10/6, which obviously brings b to be a value greater than 1. Therefore, this would be a exponential growth function. Some of you may or may not be familiar with this number e. It shows up a lot in nature. Why, we don't really know. But this number is approximately 2.71, which gives this function the properties of an exponential growth function as well. So if you ever see an e involved in a problem, much like number 4 here, or another problem such as, let's say, negative 3e to the 2x, you can know that that's an exponential growth function. I'm going to give you a short quiz here on the next page to see if you know how to identify growth and decay. If you would, take a couple of minutes and determine whether or not problems 1 and 2 are growth or decay. Alright, we're back. Problem number 1. Hopefully you determined that this function is a decay function. Its base value b equals 0.125. For the purposes of this unit and this lesson in general, I'm going to identify decay with a red highlight and growth with a blue. Looking at problem number 2, this problem will have a, whoops, I didn't want to do that in red. Okay, that's fixed. This problem will have a base value of 4/3. That negative exponent obviously will take the reciprocal of our base value, which was 3/4, and turn it into 4/3. That would be a growth problem. On to the next topic. See you soon. Alright, let's graph a couple functions. First of all, whenever you graph an exponential function, the best thing that you can do is to set your window for your x's to -1, 0, and 1. That's only when you're sketching them. Obviously on Graphing Calculator we would use a standard window of -10 to 10, and the same for our y values. So we're going to plug in -1, 0, and 1. And I'm going to show you a little bit of a trick here. 0 is a nice number because when we plug it in for x, we're going to get a value for that base 2 to the 0 power. Okay, so we'll get 3 times 2 to the 0 power on the first problem. And on the second problem, we're going to get 2 times e to the 0 power. And as we know, anything to the 0 power is 1. So this is really 3 times 1 and 2 times 1. So we know that our first point on both of these problems is going to be the point 0 and then the number given. So in this case we've got 0, 3, and here we have 0, 2. A nice starting point. Now this is all based on whatever that initial value is and then our base to the 0 power. Now a trick when we work with the other points is when you plug in -1, it's going to take our base and it's going to flip it. So this will be 3 times the reciprocal of our base. So 1 over our base, which is 1/2. So that value will be, oops, let me go back. That value there will be 3 times 1/2, which would be 3/2. Over here, again, we'll take our initial value times 1 over our base, 1 over e. Now that's a weird one. E is approximately 2.71. So 1 over e is going to be right around 1/3. Okay, so our value here would be 2 over e, which is going to be about 2/3. And here we have 3/2 on our first function. So let's graph those 2 points. Let's graph them in a different color. Let's go red. So -1 and 3/2. That's -1 and 1.5. Great. Okay, and in our second problem we'd have -1 and 2 over e. Remember, 2 over e is about 2/3. So -1, positive 2/3, right about there. As you can see, both of these problems are exponential growth functions. As we go from left to right, they will increase. Now, you should be very pleased with the third point here. When you plug in 1, you just get your initial value times your base. So we get 3 times 2, which is 6, and we get 2 times e, which I'm going to call 2e. However, that's about 6 as well. Okay, so I get 1 comma 6. Let's graph this as another color. We'll go with our only other option of black. So 1, 6. And our third point over here is 1 and just a little bit less than 6. So 2e would be right about there. Ignore my errors here, just human error. Okay, I'm going to connect these points. And what you're going to notice, you guys, is as you get further and further away in both directions, to the left you're going to approach an asymptote. That asymptote is at 0. To the right, an exponential growth function is going to accelerate off to infinity and continue.